course is on D2L, and it's done questions 1 through 22. X 1 through 22, and 23 through 33. Add those together. So as we go through this, double check my math. I did it all in a spreadsheet, so it might be screwed. But basically, all the correct ones you got, 1 through 22, whatever number that is, times 2.5, that's your 1 through 22 points. 23 through 33 will work more. So however many you got correct there, times 4.5, and then add those up, that's your raw score. Total points was 86. So if you divide that, well, your grade times 100, that should put times 100 there. Grade. And if it doesn't match what's on D2L, it should at least, what's on D2L should be higher than what you have. I can't remember if I put a curve on this one. I think that's right. You can look at these stats. There's also a thing on D2L that shows you. I guess you can't see it on camera.
Did you give us the points from all
The ones that I had you skip,
Yeah.
I just eliminated completely, like they don't exist.
Okay. Well, also, my grade on D2L is lower than the grade on here.
Okay. Is anybody else's different from?
Yeah.
Oh, what's on your little Scantron? That's incorrect with the way that calculated. So what I did is I looked at everybody's sheet and counted how many you got correct, 1 through 22, and counted how many you got through here. And I put that in my spreadsheet, and then I calculated from there. So the ones that skipped, when I do my answer key, I just skip. When I get to the ones that you guys skip, I don't put an answer on the answer key, and then the machine just ignores that. So it didn't even grade that. So there's, you know what I'm saying? As we go through this, just tally up how many you got correct here, and how many you got correct here, and it should calculate out.
Which numbers did you skip again?
I have
8, 11, 20 something. I just skipped 29. That's the one everybody figured out during the test that I did wrong. If I curve it from where it is now, I'll just give everybody credit for 29 because I know a lot of y'all figured that one out. Even though I didn't get credit for it. But just count up, just tally this up 1 through 22 as we go and tally up this as we double check it. And that should be what you graded. But if it's not, I'll fix it. So that's number one. That would be 5 significant figures, but without the period there, it's 2. You guys with me? So tally them up as we go, y'all. On your Scantron, I don't know if you can see this. Can y'all see that? This, where it's got the answer out here to the right, it will put that on yours if you got it wrong. It'll put the correct answer there. But then in the next column, it actually does them on the left. So you see that there's an A next to 31. I don't know if y'all can see that. But what I'm saying is the left column, just to the right of it, if there's a letter there, it's telling you got that one wrong. And then in the right column, just to the left, even with the number, it tells you it's wrong. My eraser here. .0356 times 3.55. That's what my calculator says. This is 4 significant figures, that's 3. So this needs to be 3. So the answer there is B. This one, there's 1 after the decimal point, there's 2 after the decimal point, so we're keeping 1 after the decimal point. The 9 rounds to 2, 1.3.
Supposed to be 2.3.
That's 2. Your test is there. 3.5 minus 1.21. So that answer was standard scientific notation. For that, we need the decimal to be right there. So 6.84 times 10 to the 1, 2, 3. extend to -3. You guys okay so far? 3, 4, 6, 5. Um, 2 turn grams into kilograms. You gotta have grams on the bottom, kilograms on top. 1 kilogram, 1,000 grams. So that should be the answer. Although it's written 1 kilogram. That should be the answer. C. Yes, we can close this door. This room runs heat at night. When I first got in here, it's like a sauna. Hopefully, nothing that's protected. Six. Millimeters. And this conversion is you multiply by 1,000. 1, 2, 3. That's exact. 3 significant figures, 3 significant figures. 34.5 millimeters. Six, 7. Density of 2.20 grams per 1 milliliter. And its volume in milliliters. 181. Divided by 2.20. That's exact. 3 significant figures, 3 significant figures. So we're keeping those, the 7 rounds to 2. That should be the answer. 82.3, and that's E. All right. Skip the next one, skip number 8. We go to 9. So skip number 8. We need 2.54 centimeters. That's exact. 3 significant figures, 3 significant figures. 298. divided by 2.54 divided by 12. 977. Three significant figures is there. The 6 does round the 7. 9.78. Selenium ion. Look at the periodic table. There's selenium, you count to the right 2 times, so it should be 2 negative. That is D. 10 should be 2 negative for selenium. That's 10. Skip 11. The amount of phosphorus contains how many protons? Again, you look at the periodic table, you find P phosphorus, and it's the 15 on there. So 12 is A. The periodic table, how many electrons are in each neutral atom of Fe? Again, you look at the periodic table. If it's neutral, it has the same number of protons. So if it's got 26 protons and it's neutral, that means it's got 26 electrons. 26. How many electrons does Mg2 plus have? It's lost 2 electrons. That's how it's positive. Here's Mg. It says 12, so 12 minus 2 is 10. So 14 is C. My answer key right so far? How many neutrons does Cl35 have? If you look up Cl, that's how many protons it has, 17. Subtract it from the mass number. 35 minus 17 is 18. Beryllium and sulfur, what is the charge on these? When beryllium is charged, find it on the periodic table, it's right here. Count to the left twice, means it's 2 plus. Find sulfur on the periodic table, you count to the right twice. 2 minus, they have the same charge, so that means the charge is balanced if you just have one of them. So BES was the answer there. 16. We good so far? Carrie's calculated those right in the spreadsheet, so we'll see. What is the forming ionic compound? Okay, magnesium fluoride, it's Mg and F. Mg is 2 plus, F is 1 minus. So I'm going to need 2 of these to balance that charge. So it needs to be F2. Cu3E2. First, you look up the charge for phosphorus. Periodic table. There's phosphorus, you got to the right 3 times, so it's 3 minus. You've got 2 of them, so you've got E, 3 minus, and E, 3 minus. Those charges add up to -6. That means we need this to add up to +6. And we've got 3 CUs, 3 coppers. How are you going to split a +6 among 3 things? Where you're going to go 2 plus, 2 plus, 2 plus. That means it's copper 2 because of the 2. Copper 2 phosphide. Just be. The lab kept calling, what do we have in the lab? Copper chloride. It kept saying cupric chloride. You use, if you use cupric, it means 2. I didn't teach y'all that naming system, but another name for this could be cupric phosphide. So these weird endings for the metal refer to a particular charge. It's it's a naming system that's kind of going away in favor of this one. So I don't tend to teach that one, and I don't think that's on the ACS test, this older style. You see it on a lot of bottles in labs and stuff because it still persists. But just in case y'all are wondering what cupric chloride was the other day. So that's B. 19. What is the chemical formula for titanium? Cyanide is Cn minus. And it tells you titanium 2. So you know you've got Ti2 plus and you've got a Cn minus. So you're going to need 2 of those. The way you write that is Ti in parentheses. Cn, and you're going to need 2 of them. So TiCN2 in parentheses. Answer is C. Okay, 20. This is saying you've got Fe, F3, and it's saying what is the charge on Fe here? And that's just this game. Fe is negative, or F is -1. You've got 3 of them, so you've got a -3 charge. You need a +3 on this charge. There's only 1 Fe, so it's all here. So 3 plus answer. Metals that cannot be, which of the following elements cannot be classified as a metal with a variable charge? Those have to be in the transition metals. Cannot be. So you've got, what is this? 21. It lists Cr, Fe, V for vanadium, cobalt, and lithium. All of these are in the transition metals. All of those have variable charges. Lithium is the only one that does not, so that's why it's the correct answer. E is the correct answer. This is 22. PCl3, both of these are non-metals. So this is when you use the di, tri, and tetra stuff. There's 1 P. Monophosphorus. There's 3 chlorines, so I go trichloride. But when the front one is a mono, you drop that off, and it's phosphorus trichloride, which is D. All right, 23. I think that quiz that I'll add some points to your test with is just going to be these 23 through 33. because that is, of course, where most of the difficulties were. So 23, what is the mass in grams of 2.48 moles nitrogen? Nitrogen is 1 mole of nitrogen straight off the periodic table. It's 14.01 grams of nitrogen. So 2.48 times 14.1. That's exact. Four significant figures, 3. So we're keeping those 3, so it should be 34.7 grams of nitrogen. Which is 34.7. That's E. For how many moles are in grams of B? 1 mole of RB. Have that one memorized. Video is over here on the bottom left. It's 85.47. I did this wrong. Grams need to be on the bottom. So let's calculate it. That's exact. 4 significant figures. 0.816 divided by 85.47. It's 3 significant figures, so we're keeping those. The 7 rounds to 4, so we should end up 5 moles of RB. And that's B.
I'm sorry, I'm trying to write it down.
You got it?
Yeah.
You want me to write it?
No, you're fine.
Okay, how many moles of aluminum are in 4.88? So it doesn't say grams, it doesn't say moles, they're kind of missing a unit. So this is what you're going to use. I'm going to use that, and that's 1. You got this now?
Oh, yeah, I got that.
So the way I do this is I will calculate it as, because I didn't come up with scientific calculators, so I always had my own way of doing this. I separate it like this. And then 23. So I just do that in my calculator, and I do the appropriate algebra here. The calculator says, for that part, 4.88 divided by 6.022. I'll go ahead and do the significant figures. There's 4 there and 3 there, so the next number over is a 3, so it doesn't round to 0. Times 10 to the, so if I take the 10 to the 23 to the top, it becomes 10 to the negative 23. 1 pound, 26 minus 23 is 10 to the 3. That should be an answer. It's A. You guys okay so far? Any questions? 26. Okay, skip to 26. Seven. Now we'll get to the long ones. Sorry about this. Two of those, two CLs, two AGs. That's the balanced reaction. You're saying, how many grams of BaNO3 that's what we're looking for, are generated when 12.6 grams AgNO3 reacts. We're going to use grams of AgNO3 on file. Grams of this. 1 mole of AgNO3, 2 moles. And 1. Oops. Was the camera on for the last one?
So-
Okay, hopefully it was. So 12 grams of AgNO3, 1 mole of AgNO3 is this many grams, and I gave it to you, 169.87. So you didn't have to calculate it. This is that molar ratio. 2 AgNO3 to 1 BA, 2 to 1. And then the grams per mole for BaNO3 2, we gave that to 261.34. That should do it. 12.6 times 261 divided by 169.87 divided by 2. Calculator says that's exact, that's exact, that's exact, that's exact, that's exact. So we've got 5 significant figures, 5 and 3. So it's 3, so the answer should be I'm going to close this other door. this room, not that outer atrium, not the other lab, just this room runs the heat at night. And then it doesn't start running the air until like right at 8 o'clock. So I come in here in the morning and it's muggy in here.
It was cold this morning.
Oh, I like it though, God. It's so nice to feel cold weather again. It's 27, so we're on 8. Up north where I was living before I started here, we get this humidity up there, believe it or not, kind of up in the mountains. It's just 10 degrees hotter here. I'm used to humidity. Man, the summer just eats me up. 28. How many moles of O2 are produced? CO2. The reaction is 2. Plus 7, O2. So that gets our mole ratio. We're going CO2 to O2. And it's asking for moles of O2, so that's all we need. CO2 is 4, O2 is 7. That's exact, three significant figures. 5.94 times 7 divided by 4. My calculator says the three significant figures, it's there, the 9 rounds is 3, so there should be a 10.4 moles of 2. I should have solved 29 because I want to put one of those on that quiz. And we can see what the correct answer is. The reaction is find the limiting reactant was kind of a hint. You have to find the limiting reactant to get the theoretical yield of this. All right. The way I would have done this when I made my key is I would have said, SN. So we've got 5.45 grams of SN. Start there. This is what we have of SN. And what we have of HF, 5.67 grams of HF. But I chose to compare SN first, so grams of SN. I'll give you that 118.71. 118.71 is 1 mole of SN. And that's what it says on the periodic table, but I still put it here for you. And then moles of SN to moles of HF. And this is 1 to 2, one of those to 2 of those. And down here, we're going to 1 mole of HF. And grams per mole for HF is 20.01. finding the limiting reactant? Times 2 times 20.01 divided by 118.71. My calculator says exact. So 4 significant figures, 5 and 3, so we need 3, 1.84, that's the 7 rounds of 3. So we need 1, and we have 5.67, so that means this is excess, and that's limiting. Did you guys do this differently? Did anybody start with HF? That's what y'all found? All right. So apparently I thought it was the other way around when I made the key. So now that we know this is limiting, I want to use that, but now I'm going to compare it to, what does it ask? The yield of this is what we're looking for. So I can actually keep here. So now, theoretical yield SNF2 SN 1 to 1, that's a 1, and then the grams per mole SNF2 is 156.71. Exact. 5 significant figures, 5 and 3, so we're looking for 3. 4, 5 times 156.71 divided by 118.71. And I saw this on a lot of your tests, 7.19 grams. But that answer isn't there, right? So I don't know where I went wrong to make these, but that should be the answer. I will very likely put that on that makeup quiz whenever we do it. We're not going to do it like Monday and probably not Wednesday, but I'll give you plenty of heads up. But these are the ones to study for that. Skip 30. So 31. And I do want you to calculate your grade. Tell me if I went somewhere stupid on my spreadsheet and calculated your grade. The reason your grade doesn't match what's on there is because it counts everything equal. So that machine, when you run it through, it gives you a percentage. But because of this, these were worth 2.5 and those were worth 4.5. Where was that? 31. Okay, this is M1, so if 355 milliliters of a 5-6 moles is diluted to the new volume, the new concentration is 0.250 m. So we're looking for some milliliters. volume, so 0.561. I'm just doing it without units. So whatever that is. 561 times 355 divided by 0.250. 3, 3, 3, so we need 3, the 6 rounds to 6, so 797 milliliters. Answer is C. That was,
31 C?
yeah, this is 32. I just solved 32.
Oh, right.
Sorry.
I was so lost for a second.
Sorry.
What's the answer to 31?
I'll go back to it.
Okay.
So that was the answer to 32. I just solved 32. My bad. All right, going back to 31. If we put, determine the mass of an ACL into, okay. So, liters. This is where I go NaCl solution because it's liters. I'm going to run out of space. So let me solve 33 over here. NaCl solution because it's liters, so I'll put solution there. We have that many liters, and then we gotta go liters, moles, and grams. Yeah. All right, the concentration is 2.55 m, which I tell you guys to go 2.55 moles per liter, and even go all the way to 2.55 moles over 1 liter. This is the way to write it. And we need liters on the bottom, so 1 liter NaCl solution. 2.55 moles of NaCl. We need moles, 1 mole of NaCl. I guess I didn't give you that one. There's one of them, Cl, there's one of them. What is sodium? $22.99. 2.99 plus 35.5. 58.44 grams. And we'll see if I did this one correct. 1.569 times 2.5 times 58.4. Calculator says that's exact, that's exact, that's exact. 3 significant figures, 3, 4, so it'll be 3, 9 rounds to 7. Is that there? 84.8. Everybody good? It's good, the wrong word. Suppose I'm good. last one, 33, can I erase? Everybody good to erase? 33. I guess I should do 30 as well. Here's 33. What volume of this solution is needed, right? So we've got 2 KCl. Did 29, should go back to 30. What is the volume needed? Liters, moles per liter. Moles to moles. Hold on, let me sketch this out before I. KCl, what is the volume needed? And then the KCl solution is. Okay, yeah, this is right. Liters of. PbNO3 solution. No, I had that wrong. 1 liter of PbNO3 solution. Okay, the wrong one. 250 liters. 1. Okay, 2.50 liters. It's 0.175 moles per liter. And then the stoichiometry is 1 PbNO3 to 2 KCl. KCl solution is 0.155 moles of KCl to 1 liter. Okay. So you're given this as a molarity and you're given this as a molarity. 0.175 moles per liter is the PbNO3 solution. 0.155 mole per liter is the KCl solution. And this is the mole ratio between these two. All right, as long as I set that up right. 0.250 times 0.175 times 2 divided by 0.155. Calculator says 5161. exact. Three significant figures, 3 and 3, so we need 5, 6, 4, the 5 rounds to 4. 0.565 liters of KCl solution. .565 C. All right, let me solve third, and then we'll review just a little bit. Can I erase? This one is actually a simple one. That is in milliliters. I just need it in liters. So if I move the decimal, it's 0.2935 liters. And that's it. That would be moles per liter, which is the same thing as capital N. .32 divided by 0.2935. Calculator says 4 significant figures there, the 6 rounds of 7, 41.98. And I guess the answer wasn't there. Or I did something completely wrong. 12.32, 0.2935. Yeah, so that should be the answer. It's not there. Okay, that's the test. Did you guys do the math and see where you landed? As long as what's on D2L is equal to or higher what you've got there, then I calculate. Is it right? Did it exactly right, the same as what's on? Okay. Yay, my spreadsheet skills survive. Here's what I have for a review. Just hit a couple of these real quick. On D2L now, there's some of these quizzes, stuff we've been doing. Visible. I've got them under test 2 practice quizzes. And I think, is anybody online right now looking at them? I'm curious if they're at the top, above the test 2 stuff, just so they're easy to find. Users.
Are we allowed to keep the test or do you need it back?
I think you can keep it.
Okay, thanks.
Maybe change the phrasing a little bit, but how many non-bonded electron pairs, I should say, non-bonded Those are synonyms. The book uses them interchangeably, and I use them interchangeably. But whenever you have oxygen on two things, I mean, the Lewis structure for oxygen is this. And these two single ones are what make the bonds. And the oxygens there's two of them. One of the oxygens is double bonded, the other one is two. But these are the missing electrons.
But that molecule is non-polar, right?
I think it has polarity.
Would the dipoles be coming from the oxygen?
Yeah, there's a dipole. This question doesn't ask that. There's a dipole there, and a dipole there. There's actually three there. But what's missing here, there's two pairs on this oxygen and two pairs on this oxygen. And it says how many non-bonded electron pairs, so that's 4. You see what I'm saying? I don't know. I think y'all can do these. Probably just. How many covalent bonds are generally form an atom with 5 valence electrons? You have some atom, and it's got 5 valence electrons. 1, 2, 3, 4, 5. How many covalent bonds will it form? It'll form a bond there, a bond there, a bond there. The answer is 3. So being able to figure out how many valence electrons and then do the Lewis structure helps you with those types of questions. I gave this one away. I found that picture online and it's got it there, so that just gives it away. I think y'all can do those. If you can't, you just ask me questions Monday. Let's look at the Lewis structures and valence electrons. That's the one I just used. What is the Lewis structure for chloroethylene? And it gives you these, and you just look at it and decide which one is correct and which one of them has mistakes on it. How many valence electrons for this? So carbon has 4, hydrogen has 2, oxygen has 6, so it's 6, 7, 8, 9, 10, 11. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So carbon has 4. You add that to hydrogen, which has 1, but there's 2 of them. So 4 plus 2 plus 6 is 12. I think y'all can do these. Bond polarity. You just look at the periodic table for this. I will do these as multiple choice on a test. I just have to come back and change this. But if these want a number, sometimes if you actually type the number in and then you look at the answers later, it's like if the answer was 2, it might say TWO instead of 2 and count it wrong. So just look at the answers after you answer these. These need a little bit of editing, but I think they're good. And then I made a bunch of these. Molecular shape. And I want to point something out here. On the I think y'all can do these. So I'll just really go through and review them. But let me mention this. Look at this question 10, the molecular shape / molecular geometry thing. Which molecule below has tetrahedral geometry? Notice I said which molecule below. That's misleading. Molecular shapes are tied directly to atoms. So in some sense, every atom in all of these has its own molecular shape. But if it happens to be a central atom, if all the other atoms radiate out from that central point, then yeah, it is the shape of the molecule. So that's what I've got in parentheses here. This is the same as asking which molecule below has tetrahedral geometry shape around its central atom. Here carbon's a central atom, here is boron, here is oxygen, here is hydrogen. So just notice that and understand what I'm saying here. Molecular shape is really tied directly to some atom in the molecule. It's only when the molecule radiates out from that central atom that it turns out that you can describe the whole molecule as being that shape. Contrast that with some of these up here, like this one. You can't describe this whole molecule in number 9 with one single word for its molecular shape. So there's a molecular shape for this oxygen, there's a molecular shape for this carbon, same. Well, that oxygen is kind of that null case that I mentioned, but molecular shapes are tied directly to any individual atom, not a whole molecule. It's only when there is a central atom that you can say the molecule has the whole molecule has that shape. And other than that, I think y'all can do these, so. Y'all just try those. And Monday, if you're confused, or Wednesday, if you're confused on any of them, ask me. But that's a review. That's all stuff I've already gone over. So I'm not adding anything new. Just we've kind of gotten off track from the info for test 2. So you guys look at those. Make sure you're comfortable with them. Ask questions Monday if you're lost on them. I'll go to the next thing. You guys good? All right, well, have a good weekend.
Thank you.